Okay, so this is the proof of concept model for the robotic gasoline dispensing nozzle system that I have just described throughout this paper. So using an Arduino Uno control board as our processor, our computer for this system, have that hooked up to the Lenovo Yoga 2 laptop, and right now it's just providing the power for the control board. The code, the sketch for this demonstration is actually up on the screen. However, it's difficult to see when filming with a camera phone right now. So it is highlighted and can be found earlier in my paper in one of the earlier sections talking about the design. So just to go over real quick, we have the Arduino Uno as our control board. We have as our sensors a US Pro water level sensor right here, and a HY electronics photo interrupter sensor or switch right here. So we're going to go ahead and demonstrate this. This is our what's going to simulate our linear actuator. It's a Futaba servo from a RC airplane, and our breadboard has all of the connections already set up and established. The red LED that you see on the breadboard indicates that we have power going to the light emitting diode on the photo interrupter switch. The LED on the water level sensor indicates we have power flowing to the sensor, so it is powered up as well. So based on the overall robotic system design that was described in the paper, this interrupter is going to simulate the photo interrupter retaining ring on the gasoline nozzle by up around the fuel tube. This water level sensor is going to represent the film style capacitive fuel level sensor that would be on the actual fuel tube that's inserted into the gasoline tank. And the servo, as we mentioned, is representing our linear actuator. So in concept, what will happen is once we obstruct the light flow in the photo interrupter, and we have no fluid on the water sensor, the servo will actuate to indicate that it has just opened the valve to begin the dispensing of fuel. Once the switch or the water level sensor is immersed in the water that's in this glass right here, that will override or send another signal to the board to tell it to disengage the servo, even though we still have something blocking the beam of light on the switch. And also, if we were to just remove the piece that was blocking the beam, so simulating that the fuel nozzle became unsecured in the tank, that would also cause the servo to go back to its off position. So I'm going to go ahead and close the laptop because all it is at this point is our power source. Everything else has been uploaded to the board. And so first we'll demonstrate the photo interrupter switch or sensor. Use a keychain to interrupt the beam, and you can see that the servo is actuated. Just like that. Next, simulate the secondary shutoff with the water level sensor. So once again, we'll go ahead, I'm just going to set this here for a second while we get the photo interrupter in place. So we'll initiate this, and then we're going to go ahead and insert the sensor into the water to show how it will also return back to its original position. Just like that. And one more time, just wipe off some of the fluid on the sensor. Photo interrupter, adjust it in my hand so we don't have any light coming through, and water. Just like that. Now, finally, to show what would happen if, say, we had a false reading on the level sensor if the fuel was kind of bubbling up, and then it settled back down, the resetting of the servo, just like that. Okay, thank you very much. Have a great night.